Hi everyone, welcome to my channel Python Tutorials. Here we'll explore tech, tutorials and so much more.
Hi everyone, welcome to my YouTube channel. I am Prachi Arora, an engineering student, and this is me doing community service for my community development project, and I am teaching Python on YouTube for 30 days or 30 hours. So this is the second lecture of the bootcamp. I will have already uploaded the first lecture. So if you have not watched it, make sure to watch it. In that you will learn how to set up the Python environment and also how to make your computer talk through the print statement. It's a very important topic, so make sure you know it. And in today's lecture you will know about the variables and the data types. It's also a basic and important topic, so let's just get started.
So yeah, before we jump into today's topic, let's quickly review the last lecture. Okay, so in the last lecture, I mainly taught you how to print statements. For example, these ones. So yeah, let's run it again and see how it gives the output. Simple 3 lines of the text. Okay, these were the strings. It's very simple, right? This works perfectly. But now, do you notice a massive limitation here? These values are completely hard coded. If I want to change the name, like if I want to write here my name instead of everyone, I have to delete the everyone and write my name manually into the source code. In the real world, programs need to handle the dynamic data, like a user typing in their own username or tracking a player's score in a video game as it changes. So, do we need a way to store data in the computer's temporary memory? So, today we are deep diving into the variables and data types. So, let's write some code for it. Okay, so let's make a new file for it. We will name it as lecture2.py. Okay, and now we'll be working in this file for today. Yeah. So, first of all, let me ask you, what is a variable? I'm sure you all have heard about it before, but if you haven't, no worries, I will tell you. The textbook definition says it's a reserved memory location to store values. Means it's just a memory location, just a place where we can store a value. Nothing very difficult, like you can take the example of your cupboard. There is a particular drawer where you keep your clothes. So it's like that. In the computer's memory, in the RAM, there is memory, and in that you put all your values. Like if I give my name, I enter my name in the computer, Prachi, and it will store that particular name in a particular text, in a particular memory location, memory box. Okay, so that location, when reserved for such a value, is called a variable. But let's use a simpler mental model. Imagine your computer's RAM as a massive warehouse filled with millions of empty cardboard storage boxes. Okay? If you throw a piece of data like number, let's say 25, into one of those boxes without a label, you will never be able to find it because you haven't got a label. You don't know which box contains 25 because all of the boxes look alike, right? So you need to have a label in that. If you have used Excel, MS Excel, you must also know there also the cells are named. It's not a similar concept, but it also works like that. Every cell has a unique name, so you can identify which cell contains which value, right? It's the same in here. So a variable is simply pasting a custom sticky note label onto that box. The box in the warehouse, you put a particular label on that box in which you have stored the value. Once you label the box, you can store data inside it. Change that data whenever you want and look inside the box whenever you need to read it. Let's see how this works in Python, okay? I will comment it out. Yeah, let me tell you this. Hashtag here is used to comment out the line. Comments, as you know, can't be seen in the output. It's only for the readers or programmers easily, so they are able to read the code easily. Okay, but let me show you how we declare a variable in Python. I will take an example as a score. If we have a score in a game, like this, score equals to 100. Simple, right? Let me clear this. Yeah, this is score. Let's break this single line of code because it trips up a lot of beginners. On the left side, we see score. This is the name name of our variable. This score is the name of our variable. Okay, see, you can see here. If you go on it, you can see the variable here. This is the variable. Okay, this is the name of the variable, a sticky note label. Okay, in the middle we have a equal to sign. As you know, in mathematics, equal to sign means both sides are equal. But in programming, this is not an equal sign. It's called assignment operator. Let me show you. Equals to is assignment operator. Okay. It works like an arrow pointing from right to left. It tells Python, take the value on the right side and assign it to the box labeled on the left side. Do you understand it now? It's very simple. It tells the computer that it has to take the value 100 and assign it to the score. So the score contains the value 100. Let me show you how it works. Print score. See, you don't have to use double quotes here. And now let's run this code. See, 100 is printed here in the output. Notice that I did not put quotation marks around the word score inside the print function. Let's see what happens if I accidentally add quotes there. As I told you, don't add quotes here. But if I add quotes, it will print score as it is, because here now it's not a variable, it's a string. This is a string and treat it as a dead text. That's what Python thinks when it sees the double quotes. So when you put in a variable name in the print statement, Python says, oh, this is a variable name. Let me go to the computer's memory, find that box labeled score and fetch whatever is sitting inside it. Okay, so let's try updating the variables now. I will remove this one. So score is 100. Okay, now if I print here, print score, okay, and then here I update the score again. Score equals to, let me do it like 75. Okay, and then I print the score again. What do you think will happen here? Which of the values will get printed in these? What do you think? Let's run it and see. Look at the output. First it prints 100, then it prints 75. The Python interpreter reads code from top to bottom. On the line 23, on the line here, it puts 50 in the box, 100 in the box, and then it says the same label, score again, and then puts 75 into that box. So the old value of the score goes to trash. It means it prints 100 first and then goes to the next line here and sees 75. So it puts the 100 into the trash and print the new value of the score. That's 75. So the old data is gone forever. Yeah, so that's it for the variables. Now let me show you how to name variables. Okay, I will clear this and then let let me show you this. Python variable naming nodes. Don't worry, it's not that difficult, just a few rules that you have to follow when naming the variables. Okay? You can't just name your variables whatever you want. Python is a friendly language, but it also has strict laws about naming variables. Let's look at what works and what will crash your program. Rule number 1. Rule number 1 is that no spaces. Okay, let me show you. If I go for username equals to Prachi and run it gives an error here. Syntax error, invalid syntax. You can see here. Look at this. It gives error because we have given space in between our variable name. So to fix it, the programmers have to use underscore mainly. Whenever we need space in between the variable name, we use underscore like this. This is the common styling convention, and it's also called snake case. Snake case. I hope you all are making notes with it, so it is easier to revise it after that. See here, now it runs without any error, right? Doesn't show anything because I have not printed it. Let me print it for you too, so you can see it works. User name. Remember, no double quotes because this is a variable name. Okay? Now let's run it. See here. Prachi is being printed, so it's working very well. Okay? And now let's go for rule number 2. Rule number 2, that's cannot start with a number. You can't start a variable name with a number. Okay, let me show you an example like this. First place equals to goal. Now if I run it, you will see it again. Here, the red first one and syntax error, invalid decimal literal. Right? Okay, so it doesn't work, right? But if I change it into place first, it will work very fine now. You can see clearly here that it works very well. Let me run it again. See, no error, so it works very well. The output is from the previous code. I will just comment it out so it's easier for you to understand the next ones. Okay? Let me print this one for you too so you know it's working. And if there is no error coming so it's working, you don't always need to print it and check it. Let me do it for you. See, the code is being printed, it's working. If a variable starts with a digit, Python's interpreter gets confused, thinking it's about to read a maths equation or a pure number, and throws a syntax error. So always start with a letter or an underscore. Yeah, you can start with an underscore too. Let me show you an example of that too. Okay, let me comment it out and I will show you this, and user equals to, let me put it as do, and it's still if I print it user, you will see it will work. See, it's working. So you can start a variable's name with a letter or an underscore. Okay, but you can't start it with number. You can add numbers and underscores after it. Also, no special symbol can be written. If you put a special symbol in your variable name, it will give an error. Like if I go for user @name equals to Joe, it will not work properly. Sorry. See, it's not going to work. It gives an error, syntax error. Okay, so it will not work. You can't add any special symbols in this, like this, this one, dollar sign, multiply sign, ampersand, brackets. You can't add these ones. Hashtag, exclamation. You can't add these symbols in here. Alright, so do you understand this much? So let's move on to the rule 3. Rule 3. Sorry. So rule 3 is case sensitivity. Okay? So Python is incredibly strict about uppercase and lowercase letters. Let's create 3 boxes that look similar but are completely independent. Okay, let me show you. Python is actually case sensitive language and it mostly works on lowercase letters. You can tell it by now, I guess, because print to use lowercase. Only in a few cases you will use the uppercase letters, but most of the commands and other syntax of Python is in lowercase. So let me show you this one. Age equals to 20. Okay, and now I will just put a capital A in the age equals to 30, and then full uppercase equals to 40. Okay, now let me print all of these. Print age in the lowercase, print age with capital A, and print full uppercase age. Now let's run it, and here is the output. You see, this is the output: 20, 30 and 40. Even though they spell the same word, Python treats lowercase age, capitalized age, and uppercase age as 3 completely different storage locations in your RAM. So to keep your sanity and code clean, always stick to lowercase letters for standard variables. It's not a clear rule that you have to always use lowercase letters for variables, but mostly all of the programmers prefer to have their variable names as lowercase. Okay, so this was it for the variable namings. Revise it again. Let's go through it again. Rule number 1 was no spaces. You can't add space in the variable name or it will give an error. Rule number 2 was cannot start with a number. You can't start a variable with a number, and make sure to also remember that. Let me add it as rule 4 only so you remember it. No special symbols except underscore. What is it? Underscore. Simple, right? So these are the main 4 rules. No spaces, cannot start with a number, case sensitivity, and no special symbols except underscore. It's quite easy, I will say. You just have to remember these simple rules, and naming the variables is very easy, but you should also always care about the context in which you are using the variables. Like for the game, you are going to use for player name, player score, player health, like that. So always use readable variable names, so if someone else is reading your code, it's also easy for them to understand what's going on with your code. Okay. Alright, so let's move on to the next part, that's the core data types. In some programming languages like C or Java, when you make a variable, you have to tell the computer exactly what kind of data is going inside that box before you even use it. Do you understand? In like I will show you. Let me show you. In C, like whenever you declare a variable, you have to give its type. Like it's an integer, so you have to give int a equals to 12, like this. Python is smarter than that. That's why I love Python, because you don't need to give unnecessary information like that. Python is smarter. It uses something called dynamic typing. It figures out the data types automatically based on the value you put in. Let's explore the 4 core data types that you will use 99% of the time, and let's also use the built-in Python tool called type to prove what they are. Okay, let me show you a little glimpse of data types. Here I prepared a little PPT. Let me show you. So main data types are integers, floating point numbers, strings, and the booleans. If you have learned any programming language, I'm sure you are familiar with this. It's not anything like this. Okay, yeah. So you know this now, variables, the containers, and storing information, how you do it, right? And these are the 4 core data types I was talking about. Integers are the whole numbers, positive or negative without decimals. Okay, decimal numbers come in this one, float. Here, real numbers containing a decimal point are the float numbers, or also known as floating point numbers. And then we have string. We put all that in the print statement. It was all strings, right? And then we come to boolean. That's only 2 logical values, true or false. Boolean is quite simple. I will show you in detail about this, so don't worry. Yeah, these are the arithmetic symbols. We will learn this later on. Okay? Let's go back to our VS Code, and let's start with some shear. I hope I'm not too fast or not too slow in these lectures. So yeah, let me show you the number 1. First one is integer. Okay, an integer is simply an whole number, positive, negative, or 0 without a decimal point, as I have said before. Okay, let me show you the integers. For example, I will take here player count. Like I said, you always have to use appropriate names for your variables. Mostly many beginners use like variable names like x, y, z, a, b's. These are also helpful, but when you are designing a fully aided program, full program or app or website or anything you want, you have to give variable names that the other person can also read from your code. So if you vaguely put xyz, no one will be able to understand what xyz is actually. So be clear with your variable names. Okay, say now players count. If you have to count players count is 4. Now here 4 is the integer. Then if we take temperature, I will take in minus, but right now it's around 40 degrees in where I live and it's pretty hot. So temperature is minus 12. So let's print out these first. I will show you like here players count. I'm simply printing these variables, okay, for now. Then I will show you the next thing, this temperature. Okay, let's run it. What do you see? 4 and minus 12. Predictable, right? Let's see now. I will now show you type. I told you about this type function. Right? Let me show you how it works. You have to go for print. In between this, we will go for type and then layers count. Okay? Again, print. In between it, type and temperature. Simple. Now let's run. Wait a minute, I will just add a print statement. Empty print statement is always added for formatting purposes, so it looks clean after you have run your code. Here you can see firstly the variables are printed 4 and 12, and after that here class int. This is Python confirming that these are the integers. It's very fun, right? How Python recognizes itself which data type it is. Many of the languages don't do that. C, C++, and Java. This is the main reason I love Python. I told you that before. Yeah, I know. Alright, let me move to the next one. I will just put it here only. Second one is float, also known as floating point numbers. The moment a number contains a decimal point, it is no longer an integer. Python classifies it as a float. Think of floats as a precise measurements. Whenever you have to go for precise measurements, like in points, whenever you are checking balance, especially, or weight of something, pi value, you have to use the decimal ones, right? So it's the same. Let me give you an example. If I go for balance itself, the bank balance, right? So here, if I go for, I have $50.50, and then if I go for, let's go for pi value only. Pi value is 3.1415. I don't remember the other digits. So yeah, and let's go for exact 0 also. 0.0. Okay. Now let's print all these. I will show you how it's printed. Balance. Print pi value value and print exact 0. Let's run it. See, 50.5, 3.1, 4.15 and 0.0. It's printing as it is, right? Now let's try printing there empty print statement, and then let's start printing their type. And type balance. Print type file value. Print type exact 0. Simple. Let's run it. Here you can see the values are being 50.5, 3.1415 and 00 as it is, and then empty line for print empty, and then you can see here float, class float. All of them are float. Even though exact 0 is technically 0, that single decimal point forces Python to classify it as class float. Floats and ints handle maths differently under the hood, which we will be seeing in a moment, okay? Don't worry, I will tell you everything. So moving on to the next data type, we have string. Strings are very fun, you know. I will show you the indexing and all that later on. As we learned in the last lecture, any characters wrapped in a single or double quotes becomes a string. Let me tell you how it does. Yeah. So if I go for name equals to double quotes Joe. Okay. And then let's go for phone number equals to, and put it also in here, 1 2 3 4 5 6 7 8 9 0. This is the phone number. See here, this is the alphabets and these are the numbers. Let me take another example. I will take as I have equals to, I will write here hello, add a exclamation, and then I will add 2 spaces and add @ bye. Do you think it will be printed? And let's just add more of the symbols, as many as you want. Right? Now let's print these. Print name. Print phone number. Print char string. Okay, let's run it. Let me refresh it again. Now you see it's running. It's exactly same. See, all the special characters are being printed here, and numbers are also being printed as it is because it's a string. Now let me show you the data types of it. Now again, print empty, print type name, print type phone number, print type and char string. Char string It's just a stupid name, don't go after it, okay? I just couldn't think of anything else right now. And you will see here the same output, string. str stands for string. Now if you look at phone number, even though it looks like a number, because I wrapped it in quotation marks, Python treats it as a text string, that is class string. This means you cannot do maths with it. Let me show you what happens if you try to add two string numbers together. Yeah, this is a very fun one. Let me show you. If you take num1 equals to 5 in double quotes, okay, and num2 equals to 10, these two in double quotes. Now if you do print num1 plus num2, normally the numbers should be added, but now it's in the double quotes. So see what's the output. The output is 510. Look at that. The terminal output isn't 15, it's 510. When you use the plus sign between two strings, Python doesn't do addition. It does something called string concatenation. It just glues the second string onto the tail of the first string. So keep that in mind, okay? You can also go for it like, I'll show you an example. str1 string 1 equals to hello space here, okay, and string 2 goes for everyone, and then I print it as str1 plus str2. Okay, now see the magic. Hello everyone, it's printed in the same one. This is called string concatenation, when you add two strings like that. So let's move towards your fourth data type, that is booleans. It's called boolean. It mainly consists of true and false. In the starting I told you that variable names, you have only a few one where you have to initially give capital letters, right? These are the ones: true, false, and null. These are the only keywords in the Python in which you use capitalized form. Okay, first letter capital, true, false, and null, out of which true and false are the booleans. Okay, booleans are the simplest data type. They cannot hold. They can only hold one of these two values, true or false. They act like logical light switches. Either it's the switch is on or it's off. True stands for 1 and false stands for 0. You know that. Let me give you an example. Is game over equals to false, or has exam passed equals to true. Okay, now if we print the type of them, print type is game over, print type as exam passed, and run it. Here we have class bool. You can see that it shows class boolean. Yeah. And make sure you do not use quotation marks here. If you type it in lowercase or put quotes around it, Python breaks. It will not consider it as booleans. So make sure you write it as it is, with capital first letter, F capital for false and T capital for true. Okay, and not in lowercase, not in double quotes, or it will take it as string. Okay. So this was it for the essential data types. There are all more data types, but these are the essential one. There are list and other data types too, but I will teach that later on. For now, this much is important. Now let me tell you about the arithmetic operations here. Because that's simple, I think I should just tell you about it. Plus, minus, multiply. Asterisk is used for multiply, and then this is the single division, floor division. Just remember, this is different. Okay? I will put it all in different lines for you. Okay. Plus, minus, multiply, and this is for single division, floor division. This is called modulo. For now, remember these ones only. I will show you the PPT also here. I showed you, right? You can see here. I will not quite sure right now. Addition simply adds two values together. You can see this one. Multiplication multiplies two values. Division returns a float. Single division one returns a float or decimal number. Okay, and floor division rounds down to whole number. And modulo it only returns the remainder. You can take a screenshot of this area. Okay, add the subtraction in it. It's simple, you know that thing. I will show you just the simple ones now. Let me show you in the ID menu. That's happy to show you there, so you can quickly learn it. Yeah, so I will just do quickly for you. 2 plus 8, 10. 9 minus 2, 7. 1 minus 9 minus 8. That looks very easy, right? 8 into 8, 64. Okay, now main thing comes here, that is these division symbols. There are three types of division in here: single division, floor division, that was double division, and modulo division. Okay, simple division is single division is simple, as you know. Let me show you only. Like if I go for 25 divided by 5, it will give me 5.0. Even if the remainder is 0, there is no decimal place, it will only return float. Okay, let's take any other number divided by 4, 5.75. Okay, but if you go for double division, you see 25 double division 5, it will give you only 5. And even if there is a remainder value, it will only give you the main quotient 5. Okay, and as for modulo, it only gives you that remainder. Like if I go for 25 modulo 5, it will give you 0. And if I go for 23 modulo 4, it will go for 3, because that's the remainder, right? Let's go for 9 divided by 9 modulo 4, 2. Let's go. It will give 1. Okay, that's simple. We have covered so much today: variables, naming variables, and then the data types, and also arithmetic operations. So let me show you the magic of dynamic typing and memory locations now. What I'm going to show you, the dynamic nature of Python. Yeah. Before we head to the final challenge of today's lecture, let me show you something incredibly cool about Python's memory management. As I mentioned, Python allows a variable to completely change its data type on the fly. Let me show you here. Like if I go for let's see mystery box. Yes, it's a mystery box, but data type we are using here. Mystery box equals to 100. Now if I print the type of this mystery box, it will give us, you know what it will give us. Let me write the second. We take the mystery box again, and now we will go for now I am or I am text. What do you think will be its data type now? Print type mystery box. Let's run it. Look at the output here now. First it was int. Wait, let me refresh. Yeah. Look at the output. First it was an int, then it became a string. Python handled this transition flawlessly. If you ever want to see the exact secret tracking ID of where a variable is currently sitting inside your computer's RAM hardware, Python gives you a function called ID. Let me show you. Where if we take x equals to 50 and then I print ID is the location of where your variable is x, it will give you the memory location. See, can you see this big number 140707? This all it's the actual physical memory address of the data inside your laptop. Yeah. Let's move to the next part now. This is the practice and homework assignment. Let's do a fast challenge. Okay. Yeah. Let's do a fast challenge together to practice what we have learned. Right? Let's write a mini program that calculates the total cost of the items in the shopping cart using the variables. Okay? I will show you. Like we will go for item price equals to, let's go for 199.99. So expensive. And then we will take quantity equals to 3 and tax rate equals to 0.05, right? So now for to calculate its total, you all must know, I'm sure you all know what happens. So still let me tell you, we will take a subtotal that's equal to item price into quantity, then total tax quantity, then enter, and total tax will be subtotal into tax rate. That's how it's calculated, right? So the final bill becomes subtotal plus total tax. I hope you all understand this much. This is the item price, quantity, and tax rate. Subtotal becomes when item price is multiplied by quantity, and total tax is subtotal multiplied by the tax rate. And final becomes, of course, becomes with subtotal plus total tax. So let's print our total bill. Your total bill is print final bill. So see this? Now let's run. See, it's done. The bill is quite coming out quite weird. Let's change it and run it again. See, your total bill is, and the Python calculated it for us like a calculator. So if the price changes tomorrow, we can, like, I just showed you how I changed the price and then run it again and it gives the correct answer. The rest of the program recalculates perfectly. That is the true power of variables. So let me give you a homework assignment to you. You have to calculate the simple interest. Okay, very simple, right? Calculate. Let me give you homework. Homework is calculate simple interest. Take the values of your own and calculate it. Okay. So that's it for today's lecture. I hope you enjoyed it. I really enjoyed teaching it. So make sure you hit that subscribe button so you don't miss the next lecture. Also drop a like if this cleared up the variables for you. And I will see you in the next session. Keep coding and practicing it. Okay. Thank you.